Hi students, welcome back. Let us continue to the Unit 2 solution in the colligative properties of second type, elevation of boiling point or ebullioscopy, or we call another one of it, or increases in the boiling point. Okay. First thing, what is the meaning of boiling point? Is the boiling point means the temperature at which the liquid is converted into gaseous. When boils is come from that state, it becomes, the definition is the temperature at which liquid converted to gaseous or gas or vapor, when it is appear, is vapor pressure of liquid becomes equal to atmospheric pressure. Okay, this is called what? Boiling point. So, now going to the elevation of boiling point. What is the meaning of that elevation of boiling point? Suppose we take an example of water. So, boiling point of water is 100 degrees Celsius. We convert it to Kelvin is 373.15 Kelvin. Okay, this is a water boiling point in Kelvin. Either it equal to atmospheric. 1 atmospheric means 1.013 bar. This is 1 atmospheric value. Okay, what is meaning? The water of 373.15 Kelvin values is equal to 1 atmospheric, means 1.013 bar. Okay, this is a pure solvent. Suppose we take a solution. So solution like aqueous glucose solution. So see here, aqueous glucose solution means what the effect when pure solvent will give a increases of vapor pressure, but when added the solid particles, that make vapor pressure goes on decreases. So indicated what? In the aqueous solution, the less vapor pressure is appear. So, and also less atmospheric pressure also appear. So, compared to water, the aqueous solution is giving more boiling point to expect. Okay, boiling point to aqueous solution to ಜಾಸ್ತಿ ಇರುತ್ತೆ compared to pure solvent, because less vaporization, we get some of the temperature to rises, giving the boiling point values of the aqueous solutions. Okay, so what the effect? The effect is called what? Elevations of boiling point. Elevation of boiling point we represented in delta TB. Okay, symbolically we represented delta TB, elevation of boiling point. So here observe, this like what? Delta TB is equal to the solution. The solution, this is having a, compared to pure solvent, this is a high boiling point. So TB means what? Boiling point of solution minus T naught B. This is called what? Pure solvent. boiling point of pure solvent. Okay, let me go for graphically, they can easily understand. So see here, this is y-axis vapor pressure, and this one to be x-axis. This is temperature in Kelvin. Okay. So just observe the compare to these two, pure solvent and the solution value is higher than the pure solvent. So we can expect early the values of pure solvent. Pure solvent values will be bigger. Okay. So we put some point, this to be called as 1 atmosphere. Okay. This is called as 1 atmosphere. Either we represented 1.013 bar. This is the line. Okay. So 1 atmosphere. This is the first line. This is called what? Pure solvent. Okay. Pure solvent. So the point we called as, this is called T naught B. Okay. When the temperature at 373 to be observed, see 373.15 Kelvin to be mentioned like that, then appear of the pure solvent giving like water is giving the temperature. Okay. Suppose we take a solution. Solution is higher the values of temperature to get a boiling point. Atmosphere, 1 atmosphere equalizer. So the second one is come from here. This is what? Solution. Okay. The solution is appear in this line. This is called what? TB. Okay. So the difference is T naught B. Okay. So now you define this delta TB is equal to what you write? Pure solution minus T naught B. Okay. So going to the definition of elevation of boiling point. The difference. Okay. This much of difference. The difference in the boiling point of, this is TB means boiling point of solution. Okay. T naught B is a boiling point of pure solvent. The definition is the difference in the boiling point of solution and boiling point of pure solvent. Clear? So now going to the derive from this elevation of boiling point. So first we consider the relationship. It is compared to be one of the relationship. The relationship is the relationship between delta TB and the small m indicated what? Molality. Okay. So the difference is delta TB is directly proportional to m, small m. So when this is directly proportional to removal to get delta TB is equal to KB m. Okay. This is called proportionality constant. In its elevation of boiling point, the KB means it is called what? Ebuloscopic scopic constant, or we call elevation constant, or molar elevation constant. These three types we call as these constant. This is very important for examinations in a problematic section. So what's the meaning of ebuloscopic constant? It's defined as it is due to boiling point produces when 1 mole of non-volatile solute is dissolved in 1 kg of pure solvent. It is called what? Ebuloscopic constant. Okay? These all to be depend on nature of solvent. Nature of solvent depend on what evaluates for. Okay? So next point to be, so going to this, delta TB is equal to what? KB M. So M means molality. Molality is defined as the number of moles of solute is dissolved in 1 kg of solvent. Okay? Number of moles of solute is dissolved in 1 kg of solvent. Okay? So M is represented to number of moles of solute. Solute we take on S. N1 is a solvent. 1 is solvent and 2 is solute. N1 is a number of moles of solvent. N2 is a solute. Okay? So same as like W1 is a weight of solvent. W2 is a weight of solute. So one more point is M. M1 is a molar mass of solvent. M2 is a solute. Clear? These points will be in your mind, they can easily understand. Okay? So now going to define about molality. So number of moles of solute. Number of moles of solute means N2. Okay, dissolved in 1 kg of solvent. Kg of solvent means what is indicated? Weight. Weight means weight of solvent. Weight of solvent is W1. Okay, this is W1. But in kg. Okay, we represented in kg. This is called what? Molality. This value substituted here. Delta TB is equal to Kb and N2 W1 in 1 kg. Okay. So next to, now going to this N2. N2 is indicated what? Number of moles of what is solute. So here, for example, number of moles of solute or solvent we consider as number of moles is equal to what? Mass, molar mass. Already discussed in the last class. So here N1 is equal to what? So mass means weight W1. This is what? M1. Here is N2. N2 is what? W2 divided by M2. This value substitute here, then make was delta TB is equal to KB into N means N2 is W2. Okay, this is M2 and W1, this is a weight 1 and in 1 kg. Okay, so here just observe these things. This is what weight. This weight of W2 is solute in a gram alirutte, but in the weight of W1 in representation of 1 kg. But we go into the both values should be converted into gram. So make this is divided by 1000 gram divided by, then make what? This is completely convert to get to back balance of gram representation. Very simple thing. Li gram alide. This weight is in a kg ಇದೆ. So ಈ 1 kg ಇರೋದನ್ನ ನಾವು ಏನು ಮಾಡಬೇಕು? ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು. How did you convert? Divided by 1000 grams. That make this 1000 gram is going to the denominator. That make was delta TB is equal to KB into W2. This 1000 is come from here. 1000 divided by M2 W1. Okay. This is what? This is called as elevation of boiling point. Okay. So now one more point is the relationship between water delta TB is equal to KB and molality. See, delta TB is equal to KB molality. So what you write? You want only the KB. So make what? Delta TB. This is going to denominate the molality. So delta T, elevation of boiling point. Elevation means temperature. This is unit is Kelvin. Okay. So molality. Molality means what? Number of moles. This is moles per in a solvent. Solvent means what you write? Weight. How much of weight? Kg. Okay. This is mole divided by kg. That make this is completely what you write. This is Kelvin. This kg is going to the denominator. This is kg. Then the mole is per mole. We call it as per mole. This is what we call Kb. Ebuloscopic constant or elevation constant unit Kelvin kg per mole. Okay. So this Kb is come from nature of solvent. So water, the water is giving 0.52 kilo kg per mole. Okay. 0.52 is the values of Kb of water. Okay. So now point is the elevation of boiling point. In this elevation of boiling point, this is a equation. Delta TB is equal to KB into W2 into 1000 divided by M2 W1. Okay. So when we know it, all the quantities easily solve out this M2 values. Okay. So let me go for the problematic. Before going to the term, let me know terms. So the term is delta TB is a elevation of boiling point, KB is a ebuloscopic constant, and W2 means what? Weight of a solute into 1000. M2 means molar mass of solute, and W1 is weight of solvent. Okay. Let me go for some problem regarding of this elevation of boiling point. Okay, let me go for one problem. The boiling point of benzene is 353.23 Kelvin when 1.80 gram of a non-volatile solute was dissolved in 90 gram of benzene. The boiling point is raised to 353.11 Kelvin. Calculate the molar mass of the solute Kb. The Kb values is given. The benzene having 2.53 Kelvin kg per mole. Okay. First we are going to given the values. Okay. First the boiling point of benzene is 353.23. The boiling point of benzene means pure solvent. Pure solvent means T naught B. T naught B is 353.23 Kelvin. Right. When 1.80 gram of non-volatile solute. Non-volatile solute means this is a weight. This is a solute means W2. How much of W2 values? 1.80 gram. Okay, right? It is dissolved in 90 gram of benzene. 90 gram of benzene means solvent. The gram is W1. W1 means weight of solvent. The weight of solvent is 90 gram. Okay. The boiling point is raised to 354.11 Kelvin. The boiling point is raised after adding the solid particle that make a solution. The weight TB. TB means what? It's the boiling point of solution. The value is 354.11 Kelvin. Right? Calculate the molar mass of solute. Molar mass means M. The solute means M2. You did calculate M2, right? So now going to the already derived some equation. Delta TB is equal to this water. Elevation of boiling point equation. This is KB into W2 into 1000 divided by M2 into W1. Okay, you consider this is what you write is molality, also defined molality. Okay, so now going to the what you want to calculate M2. M2 means molar mass of solute. So M2, so M2 taken here, that make what? This is KB W2 into 1000 divided by delta TB into W1. Okay, first we calculate the delta TB. The delta TB is TB minus T naught B. So TB values is how much? This is 354.11 Kelvin minus 353.23 Kelvin. So how much you get minus to form 0.88 Kelvin. Okay, this is the values of TB. So now substitute all the values. So KB is already given 2.53 Kelvin kg per mole. Okay, next to W2. W2 is 1.80 gram, right? Then 1000 is the unit is converted to get what? Gram per kg. Okay, this is a gram. 1000 just mentioned to get form of kg. And delta TB is 0.88 Kelvin and W1 is 90 gram. Okay, now calculate these values. So here, so gram and gram, say Kelvin, then kg and kg. This is actually going to denominator. The kg is cancelled out. So cancelled out. Remaining of unit is gram per mole. This is the unit of what? Molar mass. Molar mass is a gram per mole. So all those are simple calculations. Then solve it. Result is comes out to 58 gram per mole. This is a simple calculation. Okay. Now going to the another one. Okay, students. The next one. 18 gram of glucose is dissolved in 1 kg of water. At what temperature will water boils at 1.013 bar or 1 atmosphere? Kb values are given. Okay, 0.52 Kelvin kg per mole. Okay, so now you solved out this one here. So the given values are, see here, 18 gram of glucose. This is what? W2. This is called as weight of solute. So glucose is a solute, taken 80 gram. Dissolved in 1 kg. 1 kg of water. Water is a solvent. Solvent we taken W1. W1 is 1 kg. Either we convert it to kgs to gram. This is 1000 grams. Okay. So now next point is the values of M2 is a molar mass of solute, 180 gram. How they are formed from 180 gram? The glucose is C6H12O6. Then calculate this molar mass. Carbon 12 into 6 plus hydrogen 1 into 12 and oxygen is 16 into 6. All they get 180 gram per mole. This is the values of M2 molar mass of glucose. Okay, Kb values is given. So now you did already we know the calculation. This is delta Tb is equal to Kb into W2 into 1000 divided by M2 into W1, right? So substitute all these values here, then come from the values is 0.052 Kelvin is a delta Tb values, right? So we know the equation. What is said? At water temperature will water boils at 1.013 atmospheric, 1.013 bar values. So now we want to know it. Already the equation is elevation of boiling point. Delta Tb is equal to Tb minus T naught B. This is a boiling point of solution. This is a boiling point of solvent. Okay. So this value is here, and in this water is a solvent. So water boiling point is, already we know that 373.15 Kelvin. So pure solvent is water. So they substitute the values. They get Tb. Tb is a solution. The temperature of water boils at the solution is how much? This is converted to get. So values is 0.052 plus T naught B is 373.15 Kelvin. Now these values is addition to over to get the values is 373.202 Kelvin. This is the value it comes. Okay, it's clear. Thank you.